All right, hello and welcome to our video for our IE 441 Senior Design Project. We are Group 9, and I am Soren Wagstrom.
I'm Kundan Paudyal.
And I'm Brandon Burgess, and our project is pertaining to an assembly cell optimization from job shop to a one-piece flow transformation. So, a little introduction. Our client is a manufacturer of agricultural machinery, and our project pertains to one of their cells, one of their work cells, which currently operates as a job shop. And the objective we were given was to increase the throughput by around 30% in the production cell by improving the material flow and creating a new structure within the cell. So for our current state analysis, one of the first things we did was a spaghetti diagram. And with this, we were just tracking the movement of the operator within the work cell. So as you can see on the left, each path is numbered. And we took the distance of each one of these paths in inches based on a AutoCAD drawing we were given at the start of the project. And we multiplied it by the number or frequency of the amount of times that the operator was traveling to try and find which paths were taking up the most time and the operators are traveling the most distance and losing the most time.
And now I'm going to touch quick on the second half of the data that we collected for our current state analysis, which was the more time side of it. So as you can see up at the top right corner there is a value stream map, which basically highlights all of the individual cycle times that we got for the different parts of the products that we were tracking through their assembly process in this cell. And that data was used both for that value stream map, but also to compare against the previous data that was given to us by our client in terms of their throughput and production data for last year, where we were able to do a comparison between the sort of theoretical amount of units that they should be able to produce of the two individual products against the amount that they were actually producing last year. And as you can see, the efficiencies for those are about 63 and 64% depending on the product line. And for the actual cycle times themselves, the cycle time or the efficiencies hover more around the 80 to 85% range. So definite room for improvement on both fronts there for both time and motion data. And then in terms of our future state design, we sort of, as was mentioned earlier, we did want to focus on the transformation from the job shop environment that was currently had to more of a one-piece flow system. And there were two key changes that we had to make to the system in order to achieve something like that. The first of which being that we wanted to get rid of some of the time that the operators were spending on just like moving back and forth between different parts of the cell to collect parts for their individual assemblies. And the way that we opted to deal with that was hire an additional person or use someone who is currently in the cell who may have less to do now as a kidder / material handler whose job it is to go around and collect all of the different parts for all of the assemblies and assemble them into kits, which can then be distributed to the different members of production. And the other thing that we wanted to change and try and implement, which is probably even more important towards implementing a one-piece flow system, is the pre-painting and outsourcing of painting for some of the components that they use in their assembly, because a painted component then will have to be dried and will have to be, it'll have to get painted on the floor, and that, creates a buffer between when it can be painted and when it can go into production, and that just throws off a one-piece flow system. So we're proposing that our client does all of their painted components outsourced instead of painting them in-house. And now I'll have Kundan talk about the discrete event simulation that we did to validate the results of our model.
So as mentioned before, we took the improvements that we had in terms of cycle time, in terms of the movement reduction, as well as the new process, and then did a discrete event simulation in Simio. A picture on the left is the design of the simulation itself, and on the right are the new cycle times based off the CSA analysis, and then the percentage reduction for doing a simulation. So the simulation uses a triangular distribution with a minimum, most likely, and maximum time. And this simulation was run for about 18-hour period. And in terms of the results, we got in an 8-hour shift that with this setup, the client can produce about 10.75 units in an 8-hour shift, with the minimum being 10 and then the maximum being 12. So using the throughput and the values from the simulation, here is the kind of like the financial opportunity of the project. So with the number of units made in 8-hour shift, the client can produce about 2,300 units in a year, which is an increase of about 58 from the last calendar year. With those units, they can generate a revenue of about $9.1 million per year. And to implement the solution, there are a few cost elements. The first being labor, so to pay the people and the operators who work in the line, and also outsource the pre-painting of the parts, which comes out to about $81,000 per year. And items for a one-piece flow, such as lift tables, as well as some changes that need to be made to the job shop, come up about to be about $5,900 or so. So subtracting the cost from the gains, the client can generate a first-year profit of about $8.7 million, which is an increase of 59% over the past calendar year. That concludes our presentation. On behalf of my team, thank you very much for listening.